Okay, so hello everyone. The question which we will be solving today is maximum number of points from grid queries. Okay, the question number is 2503 and it is marked as a hard one, right? Okay, so before solving this is today's LeetCode POTD. Okay, so now let's just read the description and try to solve this problem. So you are given an m cross n integer matrix grid and an array queries of size k. Find an array answer of size k such that for each integer queries I, you start in the top left cell of the matrix and repeat the following process. Okay. So like for each query, we need to start from the top left corner. Okay. So if see, this is the following process which we need to follow. Okay. If queries I is strictly greater than the value of current cell that you are in, then you get 1 point if it's your first time visiting the cell, and you can move to any adjacent cell in all four directions. Okay. Up, down, left, and right. Otherwise, you do not get any points and you end this process. Okay, so these are the two operations. Okay, okay. So after the process I, answer I is the maximum number of points you can get. Okay, note that for each query you are allowed to visit the same cell multiple times. Resulting return the resulting answer array answer. Okay. So what does the question says is that like you will be having a matrix something like this, okay, and there will be some queries, right? And for each query, you need to start from here. Start from here and visit the cells if the query I is greater than the elements in the adjacent cells. Okay, and like you can visit a cell multiple times, but you will be getting the point when you are visiting it once. Okay, and you need to return the maximum answer. Okay, so let's just go through the example test cases and the things will be much more clearer. Okay, so for query 5, we start from the top left corner, which is this. So is 5 greater than 1? Yes. So we visit this, right? And let's say count, or let's say point is 1, right? Now we can go up, we can go down, left and right. So suppose we go right and we go left. So is 2 less than 5? Yes. So these are two different cells. So we do +1 +1. Now we see that, see, we can't go here because 5 is not greater than 5. It's equal. And similarly, from here also 5 is greater than 5, not equal to. Okay. So like we go down here and we go here. So I got like 3 is less than 5. Okay. So 1 plus 1, which is equal to 5. Okay. So this is clearly shown. Okay. So this is for the, okay. This is for the sixth query. Like you can go here, 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 and this. Okay, so how many cells did we cover? We covered 8 cells. Here we covered 5 cells. Okay. 5, 8, and here we can cover only once. Okay, so the BFS will be working for like the brute force approach. I think it will pass 17 test cases out of 21. This much you will pass, or at 17, I would say you might. I think that 17 would fail. Okay. So there is a a trick in this question. So let me just try to show you. I would say a trick or an observation. Okay, you like if you can observe it or not. Let me just show you. Let's just say that if we processed 2 first, so the point, how much point we would get? One. Okay. So we visited this, right? We visited this one. Okay. When we try to visit this 2, we failed, and when we try to visit this 2, we failed. Okay. So the point we get was 1. So let's just say after 1, like after 2, we started to iterate on 5. Okay. So the point will be okay. So tell me one thing, that the points which we will get for, like which we got for 2, we will definitely get it for 5 also, right? Because 5 is greater than 2. Okay, see the point, let me just write it. The point which you get for like 2, you will definitely you definitely get greater than or equal to for 5, right? Because 5 is greater than 2. So do we need to process this one? No, I don't think we have to, because we already did it for 2. So it is already visited. So where do we start? Can we start from this 2 and this 2? Okay, I think we can, because they weren't visited by 2, right? Okay. So the point will be 1 for this 2 and 1 for this 2. Then what we can visit? We can visit this 3 and this 3. So it will be 1 plus 1, which is equals to 4. Right? Okay. But we could have got 1. Okay. So don't worry about it. We will be doing it. Okay. Tell me one thing, that at which point did the 5 fail? This point, this point, this point, and this point. Okay. So we have processed 5. Now we are going for 6. So for 6, we will be getting this much of point, right? The point which we got for 5 and which we got for 2, right? So for 6, we will be definitely getting more points than like for 2 and for 5, like greater than or equal. Okay, so tell me one thing, that for visiting for 6, we can visit this, this, and this, and these one were already visited. Okay, so how many points we get? We get like the points for 6 will be equal to 1 plus 1 plus 1, which is equal to 3, right? So we processed it in 2, 5, and 6. Okay, so the corresponding answers were like 1, 4, and 3. If we do the cumulative sum of it, it will become 6, it will become 1. 4 plus 1 is 5, and 5 plus 3 is 8. But the output is in a different order. So, like, if you find the right answer in a like the required time complexity, you can like easily rearrange it. You can just do the mapping, and we can get our original answer. So, by mapping, you can do it. So, what I'm trying to say is that you need to visit every cell once. You just need to solve these queries. Okay, so that's our approach. Okay. So there is one more thing that didn't hit me also, like I didn't got that point. Okay, that we need to use a priority queue here, right? And let me show you why. Let's just suppose that we visited, like we have 1, 2, 3, and we have 2, 5, 7, and 3. Let me just draw it. Then we can start. So let me just also do the index, which is 0, 1, 2, and we have 0, 1, 2. For 1, we visited this. We couldn't visit this and this. So like initially we would having like 0, comma 0. We visited it. We failed at the point of 0, comma 1, and we failed at like, 1, comma 0. 1, comma 0. Tell me one thing that for this we counted, right? Count was 1. For this we didn't count. Okay, but it stayed in the queue, right? See, we are only going to consider if the like query I is greater than the grade of, let's say, I and j. Okay, let me just okay, so we can like use x and y, grid x and y. So we only considered it because here in this case query I was query, let's say I was greater than grade of 0 and 0. Okay, uh, this will be 0. Let me show you why. And this will be 0 because like if you sort it, it will become 0, 1, and 2. So for this case 2 was greater than 1, right? So we considered it, right? And for this case and this case it failed, so we didn't consider it, right? Okay, so it stayed in the queue, right? Okay, so this part is done. Now what happened that for these two cases, here it comes like here it comes like 1 comma 0, which is like 2. So let me just move it down a bit, and which was greater like okay, sorry, just a second. This will be, let me just write it a bit more clearly. Okay, so the query was like, query was 1 was, let me just okay, so query is like something like this: 2, 5 and 6. Okay. This is 0, 1 and 2. Okay, just forget this. This is what we have. This is the query which we are processing. Okay, so like query of I, grade of what will come, grade of grade of 1 comma 0, 1, 1 and 0. So if we write it, query was like 5 and this was 2. Similarly, 5 is also greater than the grid of 0 and 1. Okay, so it will pass for this and this, but let's just say it comes to here. As soon as this like this condition fails, we are gonna break. Right. So let's just like take a hypothetical situation in which something like this happened. What happened? Let me just show. Something like this happened, that the query of 1 is greater than query of, like if just a condition arises, something like query of 1, this is 5 and this is also 5, and like suppose there are elements also, like there are these elements in Q, right? Which elements? These elements. Like there was at the bottom, it was 1 comma 1, then we have 1 comma 0, and then we have 0 comma 1. So we have taken this first. So at this point you might break, but should we have break? No, we shouldn't have broken, right? So this will lead to like incorrect. This will be incorrect, right? So what if it was based on something like a number, and then like it was it was based on the minimum number, like the minimum number is like, see what number they represent. Two oh, sorry, my bad. This is 5 comma like 1 1, and this is 2, and this is also 2. So what if we just choose these twos first and then this at the last? Okay, so do we have any data structure of like something like this which works in this way? I think we have, like uh, we have what? We have many, in which like the first place will have the value. Okay. Then we will be having x, and then we will be having y. So this kind of mini heap will be there. So how should I write it? Like the declaration. Okay. So are you getting my point? Okay. So if like you should be doing it right enough because this is a good question. Okay. Uh, like this is good. Okay. So how can we like just declare it? Okay. The declaration will be something like priority queue. Then we will be having a vector. There are like three components, like the three parts. Okay. So I'm not taking a pair here. Okay. Just use a vector. Okay. Then you will be having vector of vector int, and then what we will be having here it will we will have greater vector. It's a bit long int, and then we have like the priority. So this will be a declaration of it. Okay. So we are going to use a priority queue here. Okay. So let me just go through the code, and things will be much more clear. Okay. So let me just go to the okay. So let's just come here at the main function first and see. I have made a visit. Okay. And I have made a pair ARR. So what does this do? This does the mapping. See, mapping you can do. Okay, so I don't think that that needs an explanation. Okay, we just sorted it, right? And I have taken again and pair ARA. Okay, and a previous like the previous state. We are adding it, right? L element, the index, and we have called the BFS. BFS comes previous, like the previous value. I am not like doing like this. Where did I did it? Like I was adding it like the cumulative sum, so it's also a way of like calculating it. Okay, so the previous was 2 plus the current which comes. Okay, and just pushing that to our A. Okay, in which I have the index, the original index, and the answer, right? And when we will solve it by index, we will be getting the index of the answer. Okay, see, I have again sorted it to get the index wise answer, and I have taken a vector answer in which I have put the id dot second because this previous was the second. Okay. So let me just show you the code. Okay. The code looks something like this. The BFS, it's a simple BFS. See, initially if q is empty, and the grid of I is greater than x and it's not visited, we are just going to push it in and mark it as visited. While doing the like in the while loop, what we're doing, we have taken that element. Okay, we have like identified what the number is, the I and the j. If num is greater than equal to x, what is this x? This x is the I like the query. Where is it? This is the query I. Okay. So we are just returning the count here. Otherwise, we are doing the count plus plus, and we are now popping the element. And here you can see we are just inserting the elements. Okay. We are moving in four directions. Okay, so you might be knowing this technique of uh, calculating the directions. Okay, so and at last we're just taking the count. Okay, so this is the way of doing it. Okay. So as you can see, the code is running fine, and we have solved this question. Okay, so yeah, thank you everyone. Have a nice day ahead. And the question and the question and that code link will be in the description box. Okay. So yeah, have a nice day ahead.